Modern fundamental physics is trapped at a strict mathematical impasse. General relativity operates on smooth, continuous manifolds. Quantum mechanics is built on jagged, discrete integer boundaries. When theoretical frameworks attempt to merge them, the mathematics physically grind against each other and break. The friction between these two opposing conceptions of reality generates infinities. In standard models, physicists treat these mathematical infinities as uncomputable errors, glitches that must be artificially renormalized or scrubbed out of the equations entirely to make the physics work. The theory of infinity, or TOI, recontextualizes the problem. It treats mathematical infinity not as a statistical bug, but as an ontological primitive. The universe is generated through creatio ex totalitate, carved directly out of an infinite, undifferentiated whole. This requires abandoning the assumption that physical reality is assembled from the bottom up using fundamental point particles floating in an empty vacuum. Instead, existence is generated top-down, chiseled out of an infinite substrate by strict geometric symmetry constraints. Physical reality is mathematically equivalent to absolute self-consistency. To trace the origin of physical laws, we must decompile the exact mathematical intersections where continuous thermodynamics collide with discrete topological borders. This schematic maps the foundational architecture, defining the emergence of physical space through a strict triad. The first stage is the infinite substrate, denoted by psi. This is the unbound field containing the boundless potential of all information states. The second stage is the generative constraint, or phi. This is the active geometric principle. It introduces a fundamental polarity that shatters the primordial symmetry, carving distinct boundaries into that continuous space. The final stage is the emergent finite, theta. This stable, self-correcting knot of existence is what we experience as the observable physical universe. Mathematically, this finite universe positions itself strictly as the greatest fixed point of a monotone operator acting on the infinite lattice of states. To operationalize these symmetry constraints, the framework employs a discrete computational system called the Amanda root engine. It structures the emergence of physical context entirely around algebraic invariants derived from the Fibonacci sequence. Because the universe is a tightly constrained geometric volume, rather than a loose collection of random particles, the underlying continuous laws of statistics must ultimately bow to these discrete topological boundaries. Static analytical limits reveal only part of the architecture. To test rigidity, we execute stochastic thermodynamics using Monte Carlo accumulators to sample finite topological sets over time. When continuous statistical models are applied to these discrete boundary spaces, they encounter topological phase drag. The continuous tracking natively lags, dragging the data downward toward a logarithmic limit. This chart demonstrates neutralizing probabilistic noise. Squaring the variables creates a high-pass filter. The lower blue trace flawlessly locks onto the 33.99 invariant. In 3D space, the pink trace shows extreme volatility, yet it physically orbits the structural limit of 56.91. The log residual gap between empirical runs and exact limits is not a rounding error. It is thermodynamic exhaust, the literal physical heat required to compute an infinite continuous boundary. Macroscopic probability is an illusion. Chaotic stochastic data is physically forced to orbit precise, discrete limit rails. To prove the absolute rigidity of this manifold, we look at cross-sequence contamination. We intentionally introduce an error. A pure Fibonacci spatial matrix possesses an exact discrete arithmetic mean of 60.10. Every node is geometrically locked into a highly symmetrical 3D lattice. If we inadvertently inject a pure Fibonacci integer into this native 3D Fibonacci space, a phenomenon classified as the Trojan modality, the geometry violently fractures. The continuous laws of statistics flawlessly detect this discrete topological friction. The sequence crossing permanently drags the expected mathematical mean down to a fractured floor of 47.78. This formalizes topological ergodicity. The intrinsic geometric mass of discrete integers acts as a physical funnel guiding accumulations. Within a closed golden set, stationary distributions are physically locked. The universe does not roll dice. It strictly fills a predefined topological mold. Introduce a single non-native integer, and the entire structure shatters. We can expose exactly why the structure holds by shifting from statistical thermodynamics to pure algebraic decompilation, specifically examining the core 3D Fibonacci polynomial. Manipulating this polynomial reveals the mechanics of volumetric shear. This is the exact geometric tension created when you stripped a 2D surface boundary off a 3D volume. The remaining internal mass instantly collapses into a simple 1D line anchored to a zero-dimensional origin point. Measuring the exact mass of this collapse requires executing a 4-3-2-1 differential calculus drop directly onto the Fibonacci polynomial. By Vieta's formulas, the product of the roots is exactly 4 over 546. This denominator is twice the 12th Fibonacci node, mapping directly to the 12 fundamental fermions. Factoring in the spin 1/2 dyadic operator required to describe these fermions fractures the 12th node. The resulting mathematical exhaust is exactly 1 over 137.036. This matches Pauli's fine structure constant, defining the electromagnetic coupling required to hold the 3D universe together. Physical constants emerge as the unavoidable topological exhaust generated when differential calculus shears the dimensions of the golden set. How does this continuous space handle a catastrophic mass overload without breaking its 1D structure? We test this by interrogating the continuous trigonometric wave boundary using the canonical light-witness equation. Under extreme geometric weight, the system executes the phase-amplitude ejection law. The real phase strictly refuses to bend. To survive the pressure, the boundary violently ejects 100% of the newly introduced mass orthogonally, hiding it entirely within the imaginary amplitude plane. The real line mathematically shatters, but the absolute squared magnitude of the complex amplitude perfectly locks onto the precise, discrete Fibonacci ratio of 5 over 4. The geometry maintains its 1D real coordinate by shifting infinite structural mass into unobservable complex phase space. Mapping the discrete 1D Cartesian polynomial into continuous polar phase space projects the underlying algebraic boundary as a physical angle of rotation. The linear sequence becomes a spinning, accelerating rotational vector, tracing a continuous spatial curve around a central origin. Tracing this curve reveals two critical coordinates, the golden null nodes. Here, the physical radius collapses to absolute zero, slicing cleanly through the singularity. Between these two nodes, the output of the polynomial is strictly negative. Because polar coordinates cannot draw a negative radius, the engine instantly reflects the spatial coordinates across the origin. This generates a perfectly enclosed, self-intersecting central knot, the exact geometric projection of a negative mass state, a literal void within the spiraling matrix. The dimensions of this unejected void are permanent. Its angular diameter is flawlessly sealed at exactly pi over 5 radians, reaching its point of maximum negative topological pressure at a radius of precisely negative 1.25. Twisted into a 2D rotational field, the golden ratio ceases to be a mere length. It becomes a physical angle of annihilation, carving the exact geometric boundary separating matter from the antimatter void. Every analytical layer, the fractional derivatives, the statistical sieves, and the polar projections, ultimately resolves through a single mathematical proof, the Vieta annihilation theorem. In the infinite continuous limit, evaluating the ratio of the polynomial's sum of roots against exactly twice their product triggers a violent, perfectly tuned algebraic cancellation. When multiplied by the exact volume of the golden set, the entire holistic mass of the system perfectly cancels out its own internal fractional friction. By extracting this absolute structural invariant, the mathematical manifold successfully sheds all thermodynamic noise. The process of creatio ex totalitate is complete. The self-consistency of this tightly wound topological knot replaces the uncomputable void of infinite space.